Hello and welcome to Unit 6, Lesson 16, where students will be able to determine the scale factor as a percent. Let's go right to the think about it. Number 1, Figure 1 was used to create Figure 2 by applying a scale factor. Determine the scale factor as a percent going from Figure 1 to Figure 2 showing all work. Here are both our figures. Figure 1 is a rectangle and so is Figure 2. Figure 1 has a length of 30 centimeters with a width of 10 centimeters. Figure 2 has a length of 12 centimeters and a width of 4 centimeters. Figure 2 was created from Figure 1 by applying some scale factor. To get a smaller figure from a larger figure, we needed to apply a scale factor that's less than 100%. So let's think about that as we do our work. An equation that we're going to use is the scaled figure is equal to the scale factor k times the original figure. And so that you know, k is the percent as a decimal, the constant of proportionality, and for this lesson, the scale factor. All right. Let's use the lengths of both figures to find the scale factor. We're going to substitute the figure lengths into here and here into the equation. Scaled figure equals the scale factor k times the original figure. Set up your equation. 12 centimeters is equal to k times 30 centimeters. 12 centimeters came from the scale figure, 30 centimeters came from the original figure. Rewrite the equation using the commutative property. I like to have variables on the left. So I multiplied 30 with k and I got 30k, then it equals to 12. Notice the multiplication in the 30 times k. Use inverse operations. We are isolating the variable k. So 30k divided by 30, the coefficient in front of the k, we're going to do that to both sides. So 30k divided by 30 is equal to 12 divided by 30. Simplify, and let's do the division. That's what it means. So 30 divided by 30 is 1, and 12 divided by 30 is 0.4. So 1k equals to 0.4. Convert the decimal to a percent. I'm going to take our 0.4, which is our value for k, the constant of proportionality, the scale factor, multiply it by 100%, and we get 40%. Finally, the scale factor of 40%, which is what we was looking for, was applied to figure 1 to create figure 2. These are the steps that you will have to follow in order to apply to find the scale factor in the percent problem. The conjecture is that the scale factor as a percent is a constant of proportionality, also known as the COP and K. Let's test the conjecture out. Test the conjecture 1. Use the figures below to determine the scale factor as a percent going from drawing 1, which is a little rectangle, to drawing 2, which is a bigger rectangle. In the previous problem, we went from big to small, so our scale factor was less than 100%. In this case, we're going from small to big. So we have to think opposite of small percent. We need to find a percent larger than 100%. That'll be our scale factor. Let's get into the work. There's our equation. Scaled figure is equal to the scale factor k times the original figure. Let's use the widths of both figures to find the scale factor. Here's our equation again. Set up your equation with your values. 2.4 came from the scale figure, the width of the scale figure, and 1.5 inches came from the width of the original figure. 2.4 inches is equal to k times 1.5 inches. Rewrite the equation so that the variable k is on the left-hand side. I like to keep it on the left-hand side. 1.5k is equal to 2.4. Again, notice the multiplication in the 1.5 times k. Use inverse operations. Since there's multiplication in the previous step here, we have to use division to get rid of the coefficient of k. So 1.5k divided by 1.5. What you do on the left, you do the same exact thing on the right to maintain balance. 2.4 divided by 1.5. Simplify, do the division. 1.5 divided by 1.5 is 1, and 2.4 divided by 1.5 is 1.6. Finally, convert the decimal to a percent. So k equals 1.6, multiply it by 100%, you get 160%. That is the scale factor that was applied to the little figure to get to the big figure. I'll give you a moment to look at this work before we go on to part B. All right. Part B says, test the conjecture 2. Use the same figures to determine the scale factor going from drawing 2 to drawing 1. This time we're going from the bigger drawing to the smaller drawing. So our scale factor that will be applied here to drawing 2 will be less than 100% because we're getting a smaller figure in return. Let's keep that in mind as we do our work. Here's your equation. By using the lengths of both figures to find the scale factor, scale figure is equal to scale factor k times the original figure. Set up your equation. 2.45 inches is the scaled figure length, times k, the scale factor, we don't know what that is, times 3.92 inches, which is the original width, the original length, excuse me, of the original figure. Rewrite the equation. 3.92k equals 2.45. Notice the multiplication in the 3.92k. Use inverse operations. I see multiplication, so I must do division. 3.92k divided by 3.92. What you do to the left, you do to the right. 2.45 divided by 3.92. When you do the division, you can see that 2.45 divided by 3.92 leaves you with a value of k equals 0.625. And then finally, convert the decimal to a percent. We take our k equals 0.625, multiply it by 100%. That's the same as multiplying by 100. And you get 62.5%, which is the scale factor that was applied to drawing 2, a larger rectangle, to get drawing 1, a smaller rectangle.